Point B, here we are. What we've got is the application of what we've been doing all chapter. Equations on variables on both sides, moving them around, but as we start today, we're going to have to figure out how to develop the equation that relates to the problem involved. So, have you guys ever seen the distance, rate, time triangle? Has anyone ever showed that to you? It kind of looks like this. And off to the side here, just put this. The D goes at the top, the R goes here, and the T goes there. And the way it works is, the distance rate triangle, if you cover up the top one, that means rate times time equals distance. If you cover up time, that means distance divided by rate equals time. If you cover up rate, that means distance divided by time equals rate. And so the distance rate time triangle helps us to remember our relationships. In this case, all we're going to be working on today is rate times time equals distance, which is what we have at the top. So, today we're just going to look at problems that are going in opposite directions. And so here's the scenario. As you're working through your problems today, sometimes, Brett, it might be helpful to draw a picture of the illustration with arrows or a pictorial graph or something like that to help you understand the situation. So here's the situation. Bill and Peter are leaving home traveling in opposite directions. Okay, Bill drives 10 mile an hour faster than Peter. After 5 hours, they're 550 miles apart. All right, circle the first most important piece of information in this. What are we going to circle? What's that, Jelon? Okay, so Bill goes 10 mile an hour faster. And I'm just going to write faster up here so we can just circle it all in one. So there's the first key idea. Second key idea, somebody else. Okay, after 5 hours, a time, and then they're 550 miles apart. So, what we're going to do is we're going to kind of draw a little picture of this up here. This is a very simple picture. This arrow represents Bill. Now, the other arrow is going to go which direction? The opposite direction. Okay, so we're going to make that one in black with a double arrow. Should I make this line longer or shorter than Bill's line? Shorter. Why? Because Bill is faster. Okay, so visually I'm going to make that one a little bit shorter, and I'm going to label it Peter. Now, the total distance from here to there is how much? 550 miles. And I know it seems kind of awkward to draw a picture like that, but drawing a picture like that will hopefully help you see that idea. Now, we come up back to the top. Now let's fill it in. Here's Bill plus Peter equals total. So we have to figure out what is Bill's distance, what is Peter's distance. So to do that, what we're going to do is we're going to use this little chart down here that we're going to set up, and we're going to first try to understand who we're going to use. Now, who's the slower guy? Peter. So, we're going to make him our speed. What variable are we going to use for Peter's speed? P. Always use a variable that relates to the problem. Don't just use R for rate or S for speed. Use something that relates to the problem. So, off to the side, let's put him first. So Peter is our first person. Bill is our second person. And as you just defined it, what is Peter's rate? You just defined it. What is his rate? It's P. Okay? What is Peter's time that he travels? 5 hours. And therefore, what is P times 5? 5P. So put a 5P right in there. Now, in comparison to Peter, remember Bill is faster, isn't he, Justin? By how much? 10 miles an hour. So if P is Peter, then what's Bill? No, we got to use in terms of P. Right? P plus 10. So we're going to put a P plus 10 down there. Because he's faster than Bill. We're always comparing this to one person. So that's P plus 10. Now, does he go the same number of hours? Yeah, so put in a 5 again. And now right here is probably the key idea of this example. How did I get this distance up here, this 5p? What did I do? Yeah, I multiplied rate times time equals distance. So how do I multiply rate times time? What am I going to get down here? Be careful. Talk to me, somebody. What's 5 times p plus 10? Yeah. 5p plus 10. Good morning. 5p plus 10. But make sure you put that in parentheses. Do you think it's important to have those parentheses there? Because we need to multiply the 5 by both the p and also the what? The 10. So maybe out to the side, you can put a little note that says that's 5p plus 50. So put a little note out to the side that reminds you to distribute. Now I also put a little box down here at the bottom. That's for my total. What was my total from the illustration above? 550. And now we set up an equation. The equation is going to look like this. Bill plus Peter equals total. What's Bill's distance? 5p. What's Peter's distance? 5p. I'm going to switch it to 5p plus 50 using that distributing already. And then what's my total? 550. All right, so let's solve this. 5p and 5p is 10p. Line up your equal signs. Keep those simple illustrations good. Reminding from last week, how do we solve this? Subtract 50. Now, I've made these numbers very straightforward and simple. Solving from there, divide by 10. Okay, so p equals 50. Now, what's the question? Go back to the problem and see what is the question. What is the speed of each driver? So we need to say some kind of an answer here as a sentence or a phrase or whatever. How can we say that? Peter's speed is 50 what? Miles per hour. Bill's speed is, how do I find out Bill's speed? Just do what to it? Well, how does Bill compare to Peter? Kyle? At 10. So Bill's speed is 60 miles per hour. And there we go. So, some key ideas. The slower guy gets the variable. That means it's always pluses in here. Second key idea, distribute that 5p plus 50. Third, distance plus distance equals total distance. So if we have Emily riding a bike and Matt, running, Emily's going to be faster, so Matt will be our variable because he's going to be slower. Even though he's running, she's riding a bike, so that's going to be faster. Maybe their total distance is 20 miles apart after 3 hours, and they both go on the prairie path, in different directions or something like that. Okay?